we're ready to continue with section 13.7 and looking at doing phase shifts and vertical shifts and period changes and so on for sine and cosine functions. And we will actually have lots of applications of sine and cosine functions when we're in pre-calc, and we'll do a little bit here. So here's an example of a sinusoidal function. And we have the temperatures, high temperatures, typical high temperature or average high temperature of New Orleans in Louisiana. And we can see it's warm, cold, not very cold as the average highs. So kind of it looks like a nice place to live. Now, we want to write an equation, and the first thing we need to do is look at, as you can see on your notes, is we want to look at what the period is. Now, this graph, if I didn't know the context of this, I would really like to see some more scaling on here, a little more precision on here. But we know that the pattern, this would be like January 1st, and this would be January 1st of the next year. So we know that the period is going to end up being 365 days. Now we need to figure out what the amplitude is. And remember, our amplitude, we're going to look at our high and our low. And it's not, this looks like the high is about 92 degrees. Average low looks like that's about 62 degrees. So this difference is 30 degrees of temperature, of Fahrenheit temperature. However, that's not the amplitude, remember. We have to take half of that. So the amplitude is half of that difference. So we have an amplitude of 15. Now, it's nice to, again, find where the vertical shift is, which is the next thing we have to find, and we know that that's the middle of the graph. So we know that this graph is going to have a vertical shift because it's not oscillating along the x-axis. And so we need to find halfway between these two numbers, which we can either do by finding the mean, add them together and divide by 2, or we could take 15 and subtract it away from the high to get to the middle, or take 15 and add it on to the low to get to the middle. All right, so in any case, we're going to end up getting that the vertical shift is at 77. Now our next step is we want to write a cosine function. And for our cosine function, we know cosines are going to start at a high or a low. And if I look at my graph, I can see it looks like it's a low right here, and then there's a high here, and a low. So if I'm going to do any type of phase shifting, I'm going to end up always wanting to look where my graph is at a high or a low for a cosine function. And we know our basic form for a cosine function is that y equals a times the cosine of b times x minus c plus d. So we have to find all those values. We know little a has to do with our amplitude, and we're going to either use 15 or negative 15 here. We know d is this 77. B we'll have to figure out, and C, that depends on where we're going to phase shift it. So I decided I want to write my first function. We're going to write two cosine functions. I want to write my first one starting here at a low, and I don't have to phase shift it that way. And the next one I'm going to write here, and I'm just going to start at a high. So I have to figure out what that little b coefficient is going to be. So I did that. We know that the period, which is 365 days, is equal to 2 pi divided by b. And so I calculated my little b value to be 2 pi divided by 365. And remember, this also will hold true that if p is equal to 2 pi divided by b, these two are inversely proportional. We could solve for b and get 2 pi divided by the period. That's how we can calculate our little b. All right, so we're ready. We know we're going to use a negative for the 15 because we're starting our graph down here at a low. And I'm ready to start writing. So y equals negative 15 cosine. Got my little b. I'm not going to phase shift it. If I want to write in parentheses x minus c, I may. But that equation will do it for me. Again, and that's, you can have little b, left parenthesis x minus 0 if you want to emphasize that the phase shift is 0. Secondly, I'm finding my second cosine equation. I started at a high, and notice it almost looks the same. I'm going to start the graph at a high at 182.5, and notice I'm doing my little calculation over here to find how often I have critical points. So I could accurately depict this. So when I took the period divided by 4, I know this point, let's see, 77 right here, that intersection point where it's going to be at a middle is at 91.25. Move over 91.25 more, so that's at 182.5, etc. And so I can find that location of the middle and the high very accurately. So I have my equation. And lastly, I'm writing a sine function. And that sine function, I have to phase shift it to a middle. And that's why it was important to calculate that critical point. I'm going to start it right there. At 91.25, the graph is at a middle and going up, so this should be positive. Has the same little b, because that's going to control what the period is, and it has the same vertical shift. Now the last question I have, use your equation to estimate the average temperature on day 244. Now if I go up to my graph and look at, here's 250, 244 we can see is going to be somewhere in the neck of the woods, less than 90 degrees and bigger than 80 degrees, but we would use a calculator for that. And I would be typing it in radian mode, and you should try this. You got to make sure you put your parentheses in the right spot. And now you're ready to practice on graphing and writing some equations from graphs and from doing some application questions. They're fun.